Hello and welcome to Unacademy, one-stop destination for English medium civil services aspirants. Welcome to another episode of The Geographer, where we bring to you issues and stories which are in news, which are in relevance, and which are going to be important for your examination, be it for the prelims or for the mains. Today, we discuss the massive earthquake which has struck across the coastline of Taiwan. And it has caused massive amount of damage, and even immediately after that, you had tsunami warnings being signaled across the entirety of the Pacific coastline. It is a different matter that the tsunami did not strike, but a warning was issued nonetheless. So in this video, we are going to discuss in detail that why did that earthquake occur in the region of Taiwan? What is the reason that earthquakes and volcanic eruptions are frequent along those areas? And what is its association with the aspect of tsunami? How can an earthquake end up generating a tsunami which claims multiple different lives? So all those details we are going to discuss, and also at the end of the discussion analyze what kind of question is frequently asked from this particular area. So starting first of all with the news in story. And that is, an earthquake of magnitude close to around 7.4 did strike the region of Taiwan. And the image that you see on your screen basically talks about the destruction and the shaking intensity which is reducing as you move away from the region of the epicenter. But the epicenter was along the coastal area of the region of Taiwan. Now, this is not the first time that an earthquake has struck the region of Taiwan or in this entirety of the area. This is a zone which is also referred to as the Raikou Convergence Zone. And this is a zone which has been frequented by earthquakes of varying magnitude only if you take a sample size of the past century. There also you will come across the conclusion that very massive and high intensity and high magnitude earthquakes do frequent this area. But if you analyze this region on the western coast of Pacific, and if you analyze the frequent occurrence of earthquakes in the region, you will be surprised by how frequently and how majorly the earthquakes do occur here. For example, this is the region that we are actually talking about. Now, this is an area, and this is actually a map which tells you the plate boundaries which are present and the occurrence and incidences of major earthquakes in the past few years. You will observe that while the earthquakes across the world, they are distributed in terms of their frequency, in terms of how frequently they occur, their magnitude and so on, but most of them are situated across the plate boundaries. Divergent plate boundaries, convergent plate boundaries, and so on. The region of Taiwan that you see here, basically, it lies at the boundary zone of two different plates. One is the Eurasian plate, another is the Philippine Sea plate. We will analyze these plates in detail. But just to tell you how active this region is when you consider the interior of the planet, this is a corresponding map regarding the frequent volcanic eruptions which occur in this area. And observe that when it comes to the Philippine Sea plate, that is responsible for generation of various different volcanic eruptions in the region as well. So why is it that the earthquake struck the region of Taiwan? Now, this was a resultant of the convergence of plates. But the convergence which is happening in this region is not a simple sure shot convergence that you read in your books. First of all, what do we mean by convergence of plates? Means when you have two different tectonic plates, when they come closer and they collide, they move towards each other. One plate tends to sink underneath and the other plate overrides the other one. That is convergence. Now, just in case you have no clue about what do we mean by plates. So plates are basically the divisions of the lithosphere. Lithosphere, which includes the region of the crust plus the solid portion of upper mantle, that is divided into smaller subparts. And those smaller subparts are what we refer to as the plates. For example, here you see the Eurasian plate, the Amur plate, the Indian plate, the Arabian plate, the Philippine Sea plate. These are your various different plates. So when we talk about plates in themselves, these are basically sections of lithosphere. Now, when we talk about these plates are always in motion with respect to each other. So thereby, these plates can either move towards each other, what we refer to as the converging plates. They can move away from each other, what we refer to as divergent plates, or they can end up moving parallel to each other, and that is what we refer to as the transform plate movement. Now, in this particular case, we are concerned with two of the plates, and that is what becomes relevant even for your examination, be it the prelims or the mains. Because if a question is asked regarding the earthquake occurrences in the region of Taiwan, these two plates are to be named. Which are those two plates? You have the massive Eurasian plate, and also the Philippine Sea plate. Now, why do I keep on mentioning Philippine Sea plate? Is because of that this particular plate, when we talk about it, it is made out of only oceanic crust. Whereas the Eurasian plate is a combination of both continental as well as the oceanic crust. Continental and oceanic crust. Now here, what do you observe? You observe a unique kind of convergence, in the sense that what you see here as the land area, this is the region of Taiwan. Now, this has been created purely as a result of the convergence. On one part, the oceanic crust of the Philippine Sea plate, and on the other part, the oceanic crust of the Eurasian plate. Because across the eastern margins of the Eurasian plate, you have the region around South China Sea. So that is an oceanic crust. So it is there between these two oceanic crusts where the convergence is actually happening. But just to give you a kind of a visual representation, a simple visual representation, let's consider an oceanic plate. Now, when it is going to collide with another of the oceanic plate, what actually happens? One of these will get subducted. It will start moving down. And there's a convergence, which basically means that in these particular areas, as these plates are rubbing against each other, there is never going to be a smooth movement. Because we are talking about kilometer thick of lithosphere rubbing against each other and kilometers thick rocks of high density brushing against each other. So obviously, the movement is never going to be the smooth one. The movement rather is going to be staggered and rough. Imagine if you have the fingers of both of your hands and if you try to move one against the other. Is that movement going to be smooth? Obviously not. Just like the knuckles, they offer resistance. Similarly, these fingers will also experience resistance. They won't easily overcome each other. And that is when you will have sudden kind of movement as they overcome that resistance. So that sudden movement which occurs is something which is observed across the plate boundaries as well. And when such sudden movement occurs, there is a release of massive amounts of energy, and that energy shakes up the Earth's surface in the form of earthquakes. Earthquakes, after all, are nothing but the violent and the vigorous shaking of the Earth's surface. Now, ideally what happens is that one of these plates, they go down, they subduct, go into the region of mantle. After experiencing very heavy temperatures, they start melting. The molten masses along with the vapor, they rise up, lead to volcanic eruptions on the plate margins. Now, it is these volcanic eruptions which oftentimes ends up creating a kind of a volcanic island arcs, like in the case of Philippines, Indonesia, and even in the case of Taiwan. It is a volcanic island, has been created due to ancient and older volcanoes because of that subduction of the plate. Now, what is unique in this case is that the Philippine Sea Plate is not readily subducting under the Eurasian mass. On one side of Taiwan, you will observe that the Philippine Sea Plate is actually going underneath the Eurasian plate. But from the other side, you will observe that it is the oceanic crust of the Eurasian plate which is going underneath the Philippine Sea Plate. So you have convergence which is happening across both the stretches of Taiwan, but that convergence is happening of different polarities. On one end, it is the Philippine Sea Plate which is subducting. On the other hand, it is the Philippine Sea Plate which is overriding and the Eurasian plate which is subducting. Now, why am I talking about this in detail? Basically, in order to help you understand the pressures which are experienced in these areas. Now, for example, when we talk about any such lithospheric mass, let's suppose any of that lithospheric mass you consider the top view of it. Let's suppose this is a plate. From one side, it is getting subducted. From other side, there is a subduction going underneath it. So can I say that this particular area will experience push and pull and significant amount of traction will be experienced? It will be stretched beyond the elastic limit of the rocks, something which is not very natural in this area. So slowly and steadily, there is that stretching. So in the region of Taiwan, to be more specific, to the southwestern part of Taiwan, that is in the region of South China Sea, that is where it is the Eurasian plate which is subducting. So there is some amount of traction. And then if you take a look at the northern part of it, there is another kind of traction, another kind of pull. So the entire region appears to be very stretched. The entire region is experiencing a kind of an elastic deformity. Now, ideally elastic deformity, if it is happening, why is it bad? Because once it gets expanded and stretched, there is an elastic limit beyond which the rocks cannot get deformed. The moment rocks are deformed beyond that, that is when the rocks immediately tend to come back to their original position. They tend to regain the natural state. And whenever that happens, energy will be released. And that energy is sufficient to shake up the Earth's surface. That is what occurs in the form of earthquake. So this is the reason why the region of Taiwan experiences this frequent occurrences of earthquakes, because of the push and the pull between the Philippine Sea Plate and the Eurasian plate. That is the oceanic crust of the Eurasian plate. Now, the earthquake occurred yesterday. But since that point of time, there have been significant amount of aftershocks which have happened in the area. Some of the figures basically bring that number of aftershocks to close to around 30 or 35. Now, what are these aftershocks? So, in order to understand this, imagine if, let's suppose, you have one of the rock pieces, large rock slabs. There is another one. Now, if there is a movement here, now due to that movement, there will be release of energy because the rocks are not going to move against each other smoothly. So there is going to be a massive release of energy and an earthquake which will follow. But slowly and steadily, the earthquake will also be there because the rocks will try to readjust in their new position. They will try to find the final adjustment, the stability. So whenever the rocks tend to readjust themselves, again there will be a movement, release of energy, earthquake again. So that is what is an aftershock. That is after the main earthquake. This is experienced by people as well, but also recorded in seismographs. For example, when we talk about a normal seismograph, now whenever an earthquake strikes, there is going to be a significant variation in terms of amplitude of energy released. But after that main event has passed, as the rocks they try to readjust themselves, you will have multiple of these aftershocks. They are not of the same magnitude, they don't have enough shaking intensity, but nonetheless they are disturbing. So these are your aftershocks, which occur after the main event. And they have basically rocked the entirety of the area. Now, immediately after the earthquake, there was also a tsunami warning which was generated across the coastline of Japan, Philippines, and so on. So what is a tsunami? For those of us who live across the eastern coastline, or those of us who know about the massive tsunami which hit the Indian coastline on 26th of December 2004, this is hardly a new thing. Tsunami basically brings with itself a devastating power which is unparalleled. Tsunamis, they are the Japanese terminology which means giant waves. But these giant waves are triggered how and why? So whenever there is an underwater earthquake, underwater as in under the sea, under the ocean, whenever there is that underwater earthquake, means the ground surface underneath that water body, that starts to shake up. So if the base of that water body in itself shakes up, what will happen to the water level above it? It will also be disturbed, it will also be shaken up. And that is when massive waves are generated which propagates in ideal and either directions with huge amount of speed of many kilometers per hour. So that is what causes the destruction associated. In the case of Taiwan, thankfully, the earthquake which occurred across the mainland and across the coastline, that could not trigger that tsunami. If that earthquake, on the other hand, if the epicenter would have been across the water body, it would have surely generated a very high level of tsunami. Because when you have an earthquake of magnitude close to around 7.5 to 8, that is when huge amount of energy is released. In those cases, tsunamis are always generated. Now, another thing that you have to understand here is that Taiwan is experiencing a lot of loss of lives because of this earthquake. While the loss of lives are also directly associated with the falling of the buildings, fire breakout which happens during an earthquake, earthquakes also trigger landslides and massive landslides. Because when we talk about any hilly area, any sloping region, the earthquake ends up shaking that hilly region, shaking up that mountainous area. So the slope becomes weaker. So the loose rocks, loose boulders, etc., they come down the slope, falling down the slope with ultra high speed. And they take away anything and anywhere, whatever it is lying in the way. So that is why the destruction caused is also associated with these landslides. And that has claimed a lot of lives when it comes to the region of Taiwan. Now, the region of Taiwan overall lies in the circum-Pacific zone of fire. Now, that circum-Pacific zone of fire or the circum-Pacific ring of fire is basically, if you take a look at this particular image, is the region in the entirety of the vicinity and peripheral area of the Pacific, where you have frequent occurrences of both earthquakes as well as volcanic eruptions. And that is primarily because it is a zone of subduction, where some or the other oceanic plate is undergoing subduction. Primarily, it is the Pacific plate which is being overridden by the North American plate, by the Eurasian plate from either side. So that also leads to volcanic eruptions and earthquakes. But here in this region, around the Mariana Trench and around the Philippine Sea Plate, it is the subduction of the Philippine Plate which also causes these earthquakes and volcanic eruptions. So this Pacific ring of fire is the region where Taiwan lies, and hence, in the simplest of the terms, is the reason why it is frequented by such massive earthquakes and such massive disasters. Now, from the examination point of view, what can be asked from this? Ideally, you can have a direct question regarding the plates involved in Taiwan earthquake. Which were the plates involved? So you can have a multi-choice question based upon this, right? So the answer will be Eurasian and the Philippine Sea plate. That can be an objective kind of question from the prelims perspective. From the mains perspective, you can get a question regarding the Pacific Ring of Fire, its geophysical prominence, and the various geographical events that it can lead to. This is a question that UPSC has frequently asked in the GS paper as well as in the optional area. So that completes the video. In this particular video, a quick recap. What is it that we have discussed? What happens when there is a convergence or subduction? What are plates basically? How do they converge? And what is happening in Taiwan? What has actually led to this earthquake in the region of Taiwan? What is that unique kind of subduction which is happening? How that can generate a tsunami? How are earthquakes associated with generation of tsunami? And how the various other implications to an earthquake can lead to loss of life, such as landslides and so on. So do revise this. Do take a look at the map of the region of Taiwan. And that is something which is going to help you in the examination. If you have liked the content of the video, please don't forget to click on the like, share and the subscribe button, and do watch out for the space of the geographer in order to catch up with the trending news and the relevant news for your examination for the portion of geography and environment.